Good morning, student. Class 11th, second chapter, relation and function. So, first we will discuss about the relation, and in this, the first topic is Cartesian product of two sets. In the first chapter, we discussed a lot about the sets, types of sets, then application of sets. So here to explain the Cartesian product of sets, first let a set P is given 1, 2, 3 and set Q is given 4, 5. These are the two given sets, and if we have to find the Cartesian product of these two sets, then the Cartesian product of the set P and Q is represented by P cross Q, and P cross Q will be the ordered pair of the element of set P and Q, such that the first element of the ordered pair will be the element of set P and the second element of the ordered pair will be the element of set Q. So let us see how we will write the Cartesian product. So P cross Q will be the ordered pair, and how 1, 4, then 1, 5, then 2, 4, then 2, 5, and then 3, 4, and then 3, 5. So these are the total relation defined from set P to set Q. So this P cross Q is known as Cartesian product. So what is the Cartesian product? Cartesian product is the set of ordered pair, likewise 1, 4, 1, 5, 2, 4, 2, 5, 3, 4, 3, 5, such that in the given ordered pair, the first element will always belongs to the set P and the second element of the given ordered pair will belongs to the set Q. So this type we will find the Cartesian product. Let us take one more example. Let set A is equals to ABC and set B is equals to EF. Then how we will write the Cartesian product of set A cross B? Cartesian product is represented by A cross B. Sometimes we write it A dot B also, the same meaning. So A dot B or A cross B will be the ordered pair of the element of set A to set B. So how we will write? AE, first ordered pair, then AF, second ordered pair, then BE, then BF, then CE, then CF. So these are the total ordered pair defined from set A to set B, and this set containing the ordered pair in which every ordered pair, the first element belongs to first set and the second element of ordered pair belongs to the second set. Then this is known as Cartesian product of set A and B. Now, how we will define this? So, to define the Cartesian product of two sets, we will consider two non-empty sets, and then we will define the Cartesian product of two sets. So, definition. Let P and Q be the two given non-empty sets. What is this? We have given two sets. One set is P, another set is Q, and both the given set are non-empty. Non-empty means they having some elements. Then P cross, then the Cartesian product CP. In short form we will write Cartesian product as CP. CP is defined as P cross Q is equals to ordered pair of x comma y such that x belongs to P and y belongs to Q. So what is the Cartesian product? If we have given two sets, one set is P, another set is Q, and both the set are non-empty. Non-empty means they having some element, then the Cartesian product is defined as P cross Q barabar ordered pair of the element type x comma y such that in this ordered pair the first element of the ordered pair will be the element of first set P and the second element of the given order pair belongs to the second set, that is y belongs to Q. So this is the standard definition of P cross Q. Now on the basis of Cartesian product and ordered pair, now we will do the exercise first. So first question, if exercise NCERT 2.1 question number first, what is given? If the ordered pair x by 3 plus 1 comma y minus 2 by 3 is equals to 5 by 3 comma 1 by 3, then find the value of x and y. So by the definition of ordered pair, when one given order pair is equal to the another given order pair, then by the equality of ordered pair, if two given ordered pair are equal, then first element of first order will be equals to the first element of second order and second element of first order will be equals to the second element of second ordered pair. So here by the equality x by 3 plus 1 will be equals to 5 by 3, implies that x by 3 will be equals to 5 by 3 minus 1, implies that x by 3 will be equals to 5 minus 3 by 3, that is 2 by 3, implies that x will be equals to 2 by 3 into 3. 3 से 3 cancel हो जाएगा, so x is equals to 2. Similarly, on comparing the second element of first order, that is y minus 2 by 3 equals to 1 by 3. So y will be equals to 1 by 3 plus 2 by 3. So y will be equals to, taking 3 as LCM, 1 plus 2, that is 3 upon 3. So y will be equals to 1. So this is the question number first of exercise 2.1, and this question was solved by the property of equality of two ordered pair. When the two given ordered pair are equal, by then equality of ordered pair, the first element will be equals to the first element of second order, and similarly second element of first order pair will be equals to the second element of second given ordered pair. Now question number second, if a set A has 3 elements, that is NA is equals to 3. A set A is given and it has 3 elements, and set B is equals to set B having element 3, 4 and 5. So this is also having 3 elements. So number of elements in set B is equals to 3. Now find the number of element in A dot B, that is n A cross B will be equals to NA into N of B. So here number of element in A cross B will be equals to number of element in A. How many elements are given? 3. So NA is equals to 3. Similarly, set B is given having element 3, 4, 5. So total number of element, that is NB barabar 3. So NA cross B barabar NA into NB. So 3 into 3, 9. So there will be total 9 element in A cross B. So this was the question number 2. Very easy question. Then question number 3. If one set Z is given having element 7, 8 and one more element H is given 5, 4, 2, then find first G cross H, that is Cartesian product of G with set H. So first write the set G, that is having element 7, 8 cross with H, that is 5, 4, 2. Now G cross H will be equals to, now how we will write the cross product of two set? Take the first element of G and write as a ordered pair with each element. So 7, 5, 7, 4, 7, 2, then 8, 5, 8, 4, then 8, 2 and enclosed by this curly bracket. So it have total ordered pair 1, 2, 3, 4, 5 and 6, and you can verify number of element in G cross H will be equal to number of element in G into number of element in H. So number of element in G are 2 and number of element in H are 3. So 3 into 2, that is 6. So total number of element in G cross H are 6. This was the additional question to this. You have to solve only up to this, and if you ask the number of element in G cross H, then you can find in this way. Now next, what we have to do? Now we have to find H cross G. So how we will find the H cross G? We have to find the ordered pair of H with G. So first we will write the H. So second part, H cross G is equals to H is your 5, 4, 2 cross with 7, 8. So H cross G will be equals to 5, 7, 5, 8. So 5, 7, 5, 8. Then 4, 7, 4, 8. Then 2, 7, 2, 8. So in this way, we can write the Cartesian product of set H with set G. Now if we have to find n H cross G, then it will be equals to NH multiply with n of G. So what is the NH? NH is number of element in set H. So 3, and number of element in set G, these are the 2. So 3 cross 2, that is 6. So total number of ordered pair in the Cartesian product of set H with G are 1, 2, 3, 4, 5 and 6. So this is your verification. Now question number 4. Hope the things are clear. Then question number 4, state whether each of the following statement are true or false. If the statement is false, rewrite the given statement correctly. What we have given? First, if set P is given having element m, n and set Q having element n, m. So, in the given set P and Q, number of elements are same. Implies that and P is equals to also 2 and here NQ is also 2. So, in both the set P and Q, number of elements are 2, 2 and the elements are also same. Now what? if P is equals to Mn and Q is equals to Nm, then P cross Q. Then P cross Q. What will be the P cross Q? P cross Q will be the ordered pair of Mn, mm, then nn, then nm. So this will be total 4 ordered pair in P cross Q. Now here P cross Q is m comma n, n comma m. So this statement is false. This statement is false because P cross Q is this one. So you can correct in this way. Then second, if A and B are non-empty set, question number second, A is one given set having some element, set B also non-empty set means having some elements. So if A and B are the two non-empty set, then A cross B is the non-empty set of ordered pair x comma y such that x belongs to A and y belongs to B. Let this set having the element of type x and set B having the element of type y, then A cross B will be equals to ordered pair of x comma y such that x belongs to set A and y belongs to set B. So this is the standard definition of Cartesian product of two sets. So this statement is true. Then third statement, question number 3. If set A is equals to 1 comma 2, set B is equals to 3 comma 4. This is the third part of question number 4. Set A is equals to having element 1 comma 2 and set B having element 3 comma 4. Then what we have to find? Then Cartesian product of set A with set B intersection with phi, which equals to phi. Here see, if we have to find the intersection of a given set B, here the given set B is having element 3 comma 4. If the set B is intersection with the set phi, then B intersection phi will be always phi. Now, if we have to find the Cartesian product of any set with a set which is empty set, then A cross B will be also phi. So here A cross phi is phi because one set is empty set. So this statement is true. So in this way, we can prove the question number 3. So this was about the Cartesian product and the number of element in Cartesian product, equality of ordered pair and some application. In next video, we will do the question number 5 and onward. So hope you like this video. Please like it, share it and subscribe it. Thank you.